Welcome, and thank you for the opportunity to discuss our developments at Freeform Fibers and our work on the NAVCU Harderock, sponsored direct to Phase 2 Small Business Innovative Research Program. High temperature, low dielectric constant ceramic fibers for missile applications. We are a company built along a unique technology platform, laser chemical vapor deposition, or LCVD. CVD is a common practice for high performance thin films, practiced in the microelectronics industry for decades with literally dozens of possible material combinations available. Joseph Pegna, our lead co founder, developed the ability to focus the energy required for CVD conditions, extreme thermal gradients, using laser power, which enables the growth of fibers as opposed to thin films. Our approach, developed initially in an academic setting at Rensselaer Polytechnic Institute, then moved to the University of Montreal, was spun out into a company in 2006. The co-founders represented over half the industry and academic practitioners and experts in LCVD. Our current president and CEO, Shay Harrison, was practicing LCVD separately during his PhD research at the University of Connecticut. He became familiar with Dr. Pegna and his work nearly 30 years ago when it was still an academic curiosity. After starting his career in the ceramics industry, he joined Freeform Fibers as their materials scientist in 2012 and then rose to his current role in 2020. The company has focused on demonstrating high-performance ceramic fibers in a range of material formulations with a focus on non-oxide ceramic fibers, as improvements over the state of the art in the fibers used in the ceramic matrix composites industry. In addition to the technical expertise in LCVD, the company has extensive product and market experience in their key target market segments, including carbon-carbon materials for nose tips and nozzles, for example, ceramic and graphite powders and processing, and ceramic matrix composite materials and processes. The background for this project is a challenge from the Navy to develop higher performing, thermal shock resistant electromagnetic windows. Missile ray domes and other electromagnetic windows are challenged by the increasingly extreme thermal, environmental, and structural demands of hypersonic flights. New engineered materials that exceed state-of-the-art capabilities are required to support the next generation of hypersonic vehicles. Silicon nitride is the next generation material candidate. The objective for Freeform Fibers is to develop advanced high-temperature ceramic fibers exhibiting high strength, low dielectric constant, low loss tangent, and high thermal resistance for missile and projectile system applications. Silicon nitride fibers, produced by laser chemical vapor deposition, are targeted to very specific mechanical and electrical properties for use as a reinforcement to increase the thermal shock resistance of ceramic matrix composites. Tensile strength of the fibers and how that translates to ceramic matrix composites and fiber electric properties are being characterized. Existing electromagnetic windows are limited by the properties of the materials. Brittleness in ceramics, temperature in glasses, or toughening inclusion distribution in nanocomposites are commonplace in the marketplace. Each brings challenges, whether thermal performance, processing, or a sacrifice in desired properties. Creating a reinforcing fiber to enhance thermal shock resistance of brittle, monolithic, higher temperature performing ceramics is desired. Demand exists across all Department of Defense agencies, led by Navy platforms, but also desired for Army, Air Force, and Missile Defense Agency vehicles. The solution under development at Freeform Fibers are silicon nitride fibers in a small diameter, with desirable electrical properties, such as loss tangent and dielectric constant. The end result is a silicon nitride fiber for thermostructural CMC electromagnetic windows that exhibit a combination of high strength, low loss dielectric constant, low loss tangent, and high thermal resistance. Milestone-based accomplishments, moving the technology readiness level from 1 to 6, is ongoing. Various steps of materials modification, testing, and analysis have been performed, each growing larger in scale and scope. Warfighters will benefit from the anticipated benefits, such as enhanced missile communications and guidance with high strength, high temperature electromagnetic windows made with silicon nitride fibers. Freeform Fiber's LCVD process enables the custom development and manufacture of ceramic fibers with control over composition, stoichiometry, purity, length, and diameter, allowing for creation of the highest performance ceramic composites. Performance advantages of silicon nitride fibers have been validated. Freeform Fibers has invested significantly in developed commercial relationships at levels ranging from academic to industry prime contractor to test, characterize, and further evaluate our materials. Focusing on DoD prime contractors, these relationships include Raytheon, Lockheed Martin, Northrop Grumman, L3 Harris, and Boeing. In addition, materials subcontractors who supply the system prime contractors such as Exothermics, 1TDA, ATC, and Scientex have been engaged for materials and processing support ranging from sample preparation to testing and analysis. These subcontractors will also help pull through these materials advancements to the system's prime contractors. With positive testing and characterization results, a transition to the Navy fleet would follow normal materials, qualification, and implementation protocols. Consistent with our company objectives, our transition plan involves a multi-step model. First, we are working to build awareness at the Navy DoD level. We are starting with work with system prime contractors and leading materials fabrication subcontractors. Research, development, testing, evaluation, characterization, and scaling with suitable test articles and prototype parts is going with these parties. The company desires to transition the technology to make silicon nitride fibers in scale to supply a program of record. Appropriate qualification steps and hurdles to competitive substitution will be undertaken to achieve the company's goal of supplying critical materials with unique properties, produced via a technology that is patent protected. We are executing ongoing market research to identify and quantify opportunities in the low dielectric materials markets framed by the economics of laser chemical vapor deposition relative to alternative technologies. Commercial markets such as 6G require new, low-loss materials which have significant performance advantages over organic and inorganic solutions. The scale and scope of LCVD versus traditional approaches will likely direct our focus to the most demanding high-performance, niche market needs. To wrap things up, we are a small company that is investing in our future. We have achieved ISO accreditation, preparing the operations for meeting the needs of a program of record. Please feel free to contact us, whether Shay Harrison, our President and CEO, or Jeff Vervlied, our Director of Sales and Business Development. You can also find company news and updates when we are allowed to share them with the public on our website, listed on this slide. Additionally, you can follow us on our LinkedIn page. Thank you for your time.